Okay, this is a video on geometry section 7-5. This is just a few selections that some of you told me you had trouble with. So if I don't cover something that you needed to see here, just send me a note and I can do some more problems later. I am going to start with number 8. I'm going to try and draw these, which you guys know is not my thing. So number 8 looks something like this. These are all lines. And these are all parallel. I'm not good at arrows, am I? Okay, and they tell us that the distance between here and here on this line is 5 and 5. And this one is 4, and this is x. So we can set up, because these lines are parallel, we can set up proportions between the two transversals that go across them. So if I take the top part of this line and put it over the bottom part of the same line, 5 over 5, I can make a similar ratio from the top part of this line to the bottom part of this line, which looks like this. And whenever you have a fraction equal to a fraction, we can solve it by cross multiplying. So I'm going to multiply 5 times 4, that's 20. And I'm going to multiply 5 times x, that's 5x. Divide each side by 5, and x equals 4. Now, if you put that back in here for your x, you should see that that makes sense. If the distance on this line from here to here is 5, and the distance here is 5, it means the distance parallel lines is exactly the same. So if the distance on this line is 4, then the distance between the parallel lines on this transversal should be the same as the one above it, and it is. It's 4. That's number 9. And it looks something like this. Again, some parallel lines. These are all parallel. And I have one going straight up and down here. And they tell me the space in here is 1 and 2, the distance of those lines there. And I have another line that cuts across like this. And they tell me that the space here is 2, and I don't know what this one is. So we're going to compare things that are the same. I am going to compare the distance in the top of this line to the distance of the bottom of this line. 1 over 2. And on this line, I am going to compare the top of the line to the bottom of the line. If I cross multiply, I get 2 times 2 is 4. And 1 times x is 1x, or I can just say x. X is equal to 4. And if you look at this problem, that should make sense to you also. If this distance is 1, and this distance is 2, that means this bottom distance is twice as long. So it makes sense that this distance over here would also be twice as long. All right, let's look at 14. Let's see if I can draw it. I'm not going to draw all the little markings on these. Those are parallel lines. This is a transversal. It's marked with 36 and 20 as the distance across there. You guys can look at your book with me while I do this if you're having trouble visualizing what I'm doing, but I don't have time to write down all the little markings for parallel lines. And this distance is y and 22. Again, we're going to compare things that look the same or in the same spot. So if I can make a ratio between this column and this column, I'm going to do it. I'm going to make this one 36 over 20, left over right. And I'm going to make that equal to my next transversal, left over right, x over 21. If I multiply that, I get 20 times x equal to, look at my cheat notes so I can see what I wrote that in, is 756. Divide each side by 20, and x equals 37.8. I'm going to write that right there. Now, I kind of have a choice here and I kind of don't. I could say, now that I know this spot is 37.8 and the right side of that one is 21, I could compare that to y over 22. That's really not a good idea because this is a value we found. And there's potential that we made a mistake in finding that number. So we should always, if we have the chance, go back and use the original numbers they gave us. So it is considered more acceptable to go back to the original number they gave you, the top line, the top transversal, 36 over 20, equal to y over 22. Actually, the first time I did this problem, I did do it incorrectly. I wrote down one of the numbers wrong. And so I think I had written this as 29. So my answer did come out wrong here. And if I had put the wrong answer in here for my x value, and I used it to find my y value, then my y would also be wrong. So there's less of a chance of you making two mistakes if you go back and use the original numbers they gave you. So this becomes 20y is equal to 792. Divide each side by 20, and y equals 39.6. Now, in your book, in the answer key that I sent you, they have x is equal to 189 over 5, and they have y is equal to 198 over 5. Well, I realize that does not look like the numbers I just gave you. This one is 37.8. That's what I said. And here I said this is 39.6. But if you grab your calculator, you divide 198 divided by 5, this is what you get. So if I give you an answer from the answer book that's not in the same form, do not assume you were wrong. Just go check. It's pretty easy to punch that in the calculator and check. In this triangle, they tell me that this line is parallel to the bottom. And if that is true, then the top part of this is proportional to the bottom part. So I can make a ratio between the two sides, like the left side of the top part over the bottom part, just like we were doing in the other parallel line problem. So I can put x over 6 is equal to x plus 1 over 9. If I cross multiply, I can say 9x is equal to 6 times x plus 1. If I distribute my 6, I have 6x plus 6. And I'm going to subtract 3x from each side. That gives me 6x equals here's me. See, I make mistakes too. I should have subtracted 6x. And that should be 3x equals 6. I knew that wasn't making any sense. Divide each side by 3. X equals 2. And you can always put this back in your problem and see if it really works. If this is 2, and this is 2 plus 1, or 3, is 2 6 equal to 3 9s? Well, let's cross multiply. 2 times 9 is 18, and 6 times 3 is 18. Yes, they are equal to each other, so that problem works. Right, number 16. Oh, look, I changed to green. I don't even know how I did that. But it's pretty. Okay, so I have another theorem that says if I have a line that bisects one of the vertexes of my triangle, then it creates a proportion between the side and the base and this side and this base. Now, if they're proportional, I can put them into a little proportion over here. So I'm going to do side over base, x over x minus 1 is equal to side over base, x plus 4 over x plus 2. All right, if I multiply these, if I cross multiply these, I have x times x plus 2 is equal to x minus 1 plus 4. Distribute my x. I have x squared plus 2x. I have another binomial times a binomial, so FOIL method again. X times x is x squared. Minus 1x plus 4x gives me plus 3x. Minus 1 times 4 gives me 4. Again, I have to set this equal to 0 if I want to solve what x is. So I am going to move this to the other side, and I'm going to move this to the other side. So I'm left with 0 on this side, and over here, that makes this 0. That makes that 1x, and that makes that 4. So I have 0 equals 1x plus 4. That's what I did wrong. That's negative 4. Negative 1 times 4 is negative 4. So if I now want to move that 4 back over so that I can solve this for x, I'm going to add 4 to each side. That gives me 0 here and 4 here. So 4 equals 1x or 4 equals x. Now, I can again go back and put that in my problem and see if it works. If this is 4, this is 4 minus 1, so that's 3. This is 4 plus 4, that makes that 8. And this is 4 plus 2, that makes that 6. So I have 4 over 3 equal to 8 over 6. If I cross multiply those, I get 3 times 8 is 24, and 4 times 6 is 24, and it works. And number 17. Ooh, parallel lines with 2 transversals, and they tell me that this one is x, this is x plus 5, this is 2x minus 8, and this is x plus 8. Now we know that the space between parallel lines is proportional. So I have 2 ways I can do this problem, and I don't want this to be a stumbling block to you. So if you can't remember how to set up this problem, just make sure you're always comparing similar things. So I can say this is the space. I'm going to call this 1, I'm going to call this 2. The space between the first 2 lines is 1, and the space between the second is 2. So x is in the first space and x plus 5 is in the second place. I can make a ratio between those. And I can do the same thing on the right hand side. 2x minus 8 over x plus 8. Or I can say left side of 1 and right side of 1. So x over 2x minus 8 is equal to left side of 2 over right side of 2. Either way, I'm going to end up with the same problem here. If I cross multiply, I have x times x plus 8 equals x plus 5 times 2x minus 8. And if I cross multiply over here, I have x times x plus 8 equals 2x minus 8 times x plus. So I have, even though I reversed these, I have exactly the same problem. So it doesn't matter which way you do it as long as you are consistent and compare the same things. So if I multiply this out, x times x is x squared, and x times 8 is 8x. And I have to use the FOIL method again to multiply these two binomials together. Come see me if you don't remember how to do that. X times 2x is 2x squared. I have 10x in the middle. I have minus 8x on the outside, and I have minus 40 for my last things. And then I can combine 10x and negative 8x to be 2x. So if we're solving for solving for x, I need to make my equation equal to 0. I need everything on one side. So I'm going to subtract x squared, and I'm going to subtract 8x from this side. That leaves me 0 over here. That leaves me 1x squared minus 6x minus 40. Now, to solve this one, this is not as nice as the last one. We didn't have like 1x equal to something. So I'm going to have to find x by factoring the trinomial. To make my first term, I have x squared, so I have an x and I have an x. And to make my last term, I need something that equals 40, and I'm going to ignore the negative right now. What can I multiply together to make 40? I can do 4 times 10. I can do 2 times 20. I can do 10 times 4. I can do 4 times 1. I can do 8 times 5. What I need to look for is which two things together multiply to equal 40 and add or subtract to equal 6. Well, the only one that works with is this. So I need a 4 and I need a 10. Now this is negative, which means one of these has to be negative. Negative 10 times positive 4 or negative 4 times positive 10. To decide that, I need a negative 6, so that's going to mean I need a negative 10 and a positive 4. And if you do not remember how to do this factoring, then come see me and we'll go through it again, but I'm not going to go too much in detail about it now. Now what you do is you take each of these. I'm going to jump over here so I have more room. I have x minus 10. See, these things are both equal to 0. So I have x minus 10 is equal to 0, and I have x plus 4 is equal to 0. I'm going to do this one first. If I want to solve for x, I need to get the 4 on the other side, so I'm going to subtract 4. I have x negative 4. And over here, I need 10 on the other side, so I'm going to add 10. And I have x equals 10. Now, if I put these numbers back into my drawing where all my x's are, they will both work. Let's do it really fast. So if x is 10, then I have 10 over 15 equals, if x is 10, 2 times x is 20, minus 8 is 12. And if x is 10, plus 8 is 18. If I reduce this, 5 goes into both 10 and 15, 2/3, and 6 goes both into 12 and 18, so it works. 10 works. Let's stick negative 4 in there. If x is negative 4, negative 4 plus 5 is 1. If I put negative 4 here, 2 times negative 4 is negative 8, minus 8 is negative 16, and negative 4 plus 8 is 4. Well, negative 4 over 1 is negative 4, and negative 16 over 4 is negative 4. It works, but right here I have an x all by itself. That means the distance between here and here is whatever x is. If x is negative 4, that is not a distance. We can't have a negative distance. So a negative answer is not allowed. So the only viable answer is x equals 10.